In this episode, we're going to be talking about matching sources, and in particular, when we find ourselves in a situation where daylight is creeping in, where we are unable to prevent that light source from mixing itself in with our artificial lights. So we are going to be using as an example of this a scene that we shot with a model on our shoot recently, where we were trying actually to create a scene where daylight was coming in through a window and bathing our talent in light, which we wanted to capture as a wide, as a natural scene. But then we needed to move in with the camera and capture some close work where we couldn't rely on that daylight. One of the big reasons why we couldn't rely on that daylight is because daylight changes constantly, both in terms of intensity, so your exposure is shifting up and down all the time, but also in terms of color. And I think this is a popular misconception with daylight, that it is a consistent color. The reason why that exists is actually historically because lights were tuned to the average daylight temperature of the biggest market for film lights and film equipment generally, which is Hollywood. But you have to be able to actually measure and read the color temperature of the daylight that's coming into your location so that you can then accurately set your lights to match. This, of course, becomes much easier when you have lights that are bicolored, or as is the case with the Geminis, where we have full RGB and WW, so a daylight white and a tungsten white mode. We can actually fully tune that Kelvin from blue to yellow. So it could be, for example, skin tone. This is our shot, as I said, of our talent. She was sipping a coffee with this commercial. We have the daylight. This is our Geminis. You can see the light coming in and hitting her eyes. We've actually shaped the light. We've actually used some gaff to make essentially a cross across the middle of the trace frame that our light was going through in order to create the look of a window as the catch light in the eye. That's all artificial light that's coming in there and hitting our talent's face. And we've matched that to the color temperature of the daylight that was actually coming into the location. Because there are so many windows in the location we were using, we were unable to block them all out. It would have been extremely costly, in fact, if we have come prepared and with the manpower and the equipment to completely block out all natural light in that scene. So rather than trying to fight against it, and knowing that we only needed to shoot for very short periods, because this was a very short scene that we were shooting, we knew that we would be able to get away with this if we used what we knew about measuring the color temperature of the daylight that was coming into the location and then matching that with our lights by tuning them to match exactly. But we also had a situation here where we have the main pack shot for this particular commercial that we are working on. Again, lots of natural light that was coming in here. We kind of wanted that, actually. It was thankfully an overcast day, so we had relative consistency in terms of the exposure not going up and down too much. And again, we were only shooting for very, very short windows. By matching our lights precisely to the color temperature that we were reading of the daylight that was coming into this location, we're actually able to produce an image that, this is the ungraded image, and this is the graded image. The contrast and saturation I've worked on, but I actually haven't changed the color temperature or had to offset the hues in any way of this image. This is a very, very accurate and representative example of the brand colors that were in place on this client's packaging, which is of the utmost importance in this type of commercial work. But if you see in the behind the scenes the amount of natural light that's coming in and how we're using 2-3 different Geminis to actually light this whole scene, the reason why there's minimal or no noticeable color shifts or mixed lighting issues, with blues in the background or problems with color on the actual product itself, is because we've used this very basic and simple idea of not assuming that daylight is 5,600 Kelvin, but actually measuring it and then matching it at the location where we're filming. So when it comes to measuring daylight color temperature, the easiest thing you can do is actually use the equipment you already have with you. Your camera probably can and should tell you the Kelvin, the white balance reading when you manually white balance. So if you use a white balance card, place it into your daylight and make sure all other artificial light sources are off. Make it sure it's facing directly into where the daylight's coming from. Point your camera at it, manually white balance, and then you should see a reading on the camera. So we're using a Canon C200. It will show us the Kelvin value and also a color correction value, a CC value, which will account for any green or magenta shift that it's detecting. And that's the camera's way of saying, right, this is where white should be. We can actually borrow that information and we can load that up into our Geminis. And despite me being a colorist, actually, I really love and embrace it when I get images that are consistent in camera, that they've already recorded an image that is very close to ideal. The reason being, it means I can use that time instead of corrective work to more creative work in terms of adding depth to that image or drawing the viewer's eye to certain areas within the frame. So using this technique to just use the camera to white balance, using the daylight as our source, taking that information, loading it up into our lights, we can then create a homogeneous environment where we're happy that the light temperature has very little variance. We can then carry on shooting. One thing I would recommend though is that even though you first of all white balanced to see what the color temperature of the daylight was and then set your lights to match, I would still, before you actually roll, use the white balance chart one last time once all of your artificial lights are on as well to do another white balance. Now, the reason for that is, firstly, whilst you were setting up those lights and just entering in those values, probably the daylight's shifted very slightly. But also now that you've got your artificial light on there, it's spreading a much wider and more varied angle of light, which may well be reflecting off surfaces that the daylight wasn't, and may well be then falling onto your talent, onto your subject. And you should find that if you do that, when you get back and actually look at the image that you've captured, it's very, very close to being spot on, and you shouldn't actually have to do a huge amount of work. So both before and after the grade, we can see that it's all orbiting around a consistent white point. There's very little extra work to do in post-production because that white point was established by the camera sampling the subject once we'd already made a few, I mean, not much effort, but a few efforts to make sure that our artificial lights were in sync as close as they can be to the daylight that was coming into our mixed environment. It's all about understanding how color frequencies vary from subject to subject, understanding that daylight isn't always 5,600 Kelvin, and understanding that when light bounces off of various different surfaces, anything with a color in it, it's going to be affecting the light that finally lands on your subject. And so using a proper white balance with the camera and proper color accurate lights will ensure that you can tune in exactly the matching color temperature that you need to and get really good, consistent results every single time.